Good morning, everyone. My name is Honja Ramanandraibe, and I'm a PhD student in petroleum engineering. My mini research topic for this course that I'm going to discuss today focuses on the use of reservoir simulation to predict coal seam gas production. For a better understanding of the topic, I divided into sections, including a brief introduction, followed by an overview of reservoir simulation and coal seam gas, then a case study in which the methodology used and results will be detailed, and the last section relates to the conclusion. To begin with, have you ever asked where the gas you use in your kitchen to cook or the energy that heats your home comes from? The energy we use to support the whole range of human activities comes from a variety of sources, but fossil fuels provide the majority of our energy on a global basis. As a result of the increase in worldwide energy demand, the interest in unconventional resources, such as coal seam gas, has increased. Forecasting their production plays a crucial role in the decision-making and investment scenario evaluation. Different methods can be applied to predict well performance, such as decline curve analysis, which is a classical approach, but we will be looking at another alternative to forecast hydrocarbon production, which is numerical reservoir simulation. So let's see what is the reservoir simulation and its importance, or simply why simulate. Reservoir simulation can be described as the application of a computer simulation system to characterize the fluid flow in a reservoir. It is a valuable tool to understand the oil and gas reservoir behavior and performance under various operating strategies. The top right figure here illustrates the data required for reservoir simulation. In addition, reservoir flow modeling is the most sophisticated methodology available for achieving the primary reservoir management objective for hydrocarbon reservoir, which is to determine the optimum conditions needed to maximize the economic recovery of hydrocarbons from operated field. In this case, we will explore how reservoir simulation can be used to predict coal seam gas well performance. So let's see what is coal seam gas. Coal seam gas, also known as coal bed methane, occurs naturally in varying quantities in coal seams and consists mainly of methane. The gas that accumulates underground and is kept in coal seams is formed during coalification, which is the long geological process of coal formation when organic matter is converted into coal. The majority of coal seam gas reservoirs exhibit low permeability and require advanced well stimulation technologies, namely hydraulic fracturing, to achieve economic production rates. It is worth noting that the modeling and production forecasting of such reservoirs are challenging because of their characteristics. To further understand the importance and role of numerical reservoir simulation, a coal seam gas well located in the Surat Basin will be investigated. As shown in the right figure, coal seam gas in the Surat Basin represent a potential source of natural gas for Australia. So the next section details the workflow for evaluating coal seam gas well performance using a pressure-dependent reservoir simulator. In this case, we used a software called CMG. Basically, the methodology is based on the process of history matching, which is a technique that attempts to match stimulated with field result by adjusting various input parameters within a reasonable range. The top right figure here illustrates this process. So the first step here is to construct a reservoir model that represents a Bioink fractured well and considers permeability and isotropy, as shown in the bottom left figure. This model is then used to history match pressure and production rates. Once a reasonable match is achieved, then sensitivity analysis can be done with different permeability and isotropy ratios. and assess the effect of this on the reservoir deliverability. So what are the key findings? It was observed that a low permeability anisotropy ratio yields better well productivity, and cumulative production and recovery factor decline with higher permeability anisotropy ratio. To conclude, a numerical reservoir simulation is a valuable tool for forecasting hydrocarbon production, understanding reservoir behavior, and optimizing field development plans.